So let us come to the system of particles and the rotational motion. So first of all, we should have an idea about the rigid bodies. So what are rigid bodies? So a rigid body is a body with a perfectly definite and unchanging shape. So the shape should be fixed one. It shouldn't be changed. And the distance between all pairs of particles of such body do not change. So the shape will not be changing, and as well the distance between the pair of particles, that means a system of particles. A rigid body is a system of particles, so there are many particles will be there in the rigid body. So the distance between these particles should be a fixed one, that should not be changed. And now a rigid body can perform a pure translational, pure rotational, and as well the translational along with the rotation motion, that is a rolling motions. So translation along with the rotation is known as the rolling motion. Pure translation means the linear motion, and pure rotation, only the rotation will be there will be no linear displacements. So let us come to the pure translational motion. Pure translation, there is no rolling or no rotation will not be there, only a linear movement will be there. The particles will linearly move along with the system. So here the translational can be also, it is also one another time also it is given, that is the sliding. So translational motion of a block is given on an inclined plane, where you can see the particles P1 and P2, both the particles are having the same velocity. In the linear motion or the translational motion, the velocity of the particles in the system are equal because same magnitude and the same direction. But in the case of the rolling motion or the rotational motion, the velocity are for the particles from point to point, the velocity values are different. Now the rolling motion. In the case of the rolling motion, it is having both the translational and as well the rotational motions. Okay. So translation means the displacement is happening from A to B. From A to B, a displacement is happening. And the rolling means, suppose if you are considering a point P3, after a few minutes it will roll and it will come up at the upper portion. Means both the rotational and as well the linear motions are there in the rolling motion. So the rolling motions are not a pure translational or pure rotational motion. Here you are having 4 points P1, P2, P3 and P4. So the velocity directions are given for the P1, P2 and P3 and as well the P4, the velocity directions are given. For P1 and P2 you can see that the direction of the velocity is same, in the same direction it is there. So in the rolling motion, the velocity values of the particles may not be a constant. Here at the point P3, the particle at the point P3 will be having the velocity value 0, whereas the P2 and P1 is having same velocity, but the value of the P4, maybe the magnitude may be same, but the directions are different. Direction of P4, the direction of the velocity of the particle at the P4 is in the direction of the tangent at the point P4. Okay. Now, so we can say in the case of the rolling motion, the velocity values of the particles are different. Now come to the pure rotational motion. So rotation of a body about a fixed axis, where every particle of the body moves in a circular motion, a circular path will be there, and the plane where the particles are actually perpendicular to the axis of rotation, and the axis of rotation will be the center. Actually the center of the rotation will be upon the axis. And one more thing, suppose a particle is there upon, at the axis of rotation, and there will be no velocity. Actually, that will be at a rest only. The particles at the axis of rotation having zero velocities in the case of the pure rotation, zero angular velocity in the case of the pure rotation. In some cases, the axis of rotation will not be a fixed one. The axis of the rotation will change. The direction of the axis of rotation changes. The example is given, that is the rotation of a top spinning in a place. You can observe here, that is its edge or the sharpened edge is fixed at the point O, but the top is moving, the axis of the top is moving in various directions. Okay. So here the axis is not fixed, but the edge, the point upon which the rotation is happening, it is fixed, but the axis is varying from point to point. You can see here the axis of rotation is here. Here in the given figure, the axis of rotation here, and the axis of rotation can be over here, here. Likewise, it is changing from point to point. So in such cases, the axis of rotation that is not fixed, and the vertical formation around the axis, which is termed as the precession. So the movement of axis of the top around the vertical is termed as the precession, where the axis it is moving. Okay, axis it is moving, axis it is not fixed, but the point upon which the the top is rotating, or the rotation is happening at a fixed point. That point it is fixed only. There is no changes in the case of the point. That means there is no translational displacement is not happening, but the orientation of the axis is changing continuously. And the vertical plane or vertical term or vertical portion which is formed due to the orientation of the axis or the change of the position of the axis, it is known as the precession. Now in the case of the top, and as well in the case of a table fan. In the table fan, the axis of rotation it is of the blades it is given. This is the axis of rotation. And along with that one, what is happening? The spinning. If you are spinning the fan, if you are turning on the spinning, the face of the fan will change, rotate again in this direction and in this direction. So for that one, the axis of oscillation will be this one. Okay, the axis of oscillation will be this one. So here, as a result of this oscillation, it means here the point is fixed over here. The point of rotation it is here, that is at O, and along with that rotation, the spinning is also happening. The face of the fan is also changing. That means the axis of rotation it is changing continuously. Okay. Now, so the motion of a rigid body which is not pivoted or fixed in some way is either a pure translational or a combination of translation and rotation. So if the axis of rotation is not fixed at a point, then such movements are maybe a pure translational or a rolling motion. And if there is a fixed point, and upon that point, on the basis of that point, if the rotation is taking place or the movement it is taking place, such movements are the known as the pure rotational motions. Such movements or the motion, it is known as the pure rotational motion. Now come to the next concept, that is the center of mass. So if you are considering a system of particle, so each particle is having various masses. The center of mass is actually the point where the total mass of the system is concentrated. Okay, so here in this figure we can see two particles m1 and m2, two particles of mass m1 and m2. It is given the axis of rotation, or the origin, it is the axis of rotation is this one. Okay, m1 and m2 axis of rotation, or we can say the origin. So distance of particle 1 from the origin, it is x1, and the distance of particle m2, of particle of mass m2 from origin, it is x2. Now you have to find out the point at which the center of mass is situated. So the equation to find out the coordinates of that center of mass is actually x is equal to, x is actually we are considering only a one dimensional only, we are considering only a linearly the m1 and m2 are arranged linearly. So it is not in a plane, just on the one of the axis, x axis. Okay. So we have to find out the coordinate, that the x coordinate of that center of mass. So for that, x is equal to m1 into x1, that is mass of the first particle into the position of the first particle, plus mass of the second particle into the position of the second particle, okay, divided by the total mass m1 plus m2. There are only two particles in the case of this system, so m1 plus m2 is actually the total mass of the system. So m1 into, it is the mass of the first particle into displacement of first particle, position of first particle, plus m2 into x2 divided by m1 plus m2. That is actually the coordinate of the center of the mass. Now, if masses m1 and m2 are equal, that is m1 and m2 are equal, and we can say m1 and m2 is equal to m, then m1 x1, that is mx1 plus mx2 divided by 2m, m plus m, 2m, is x1 plus x2 divided by 2. x1 is the position of the mass A, first mass from the origin, and x2 is the position of the second mass from the origin. So x1 plus x2 divided by 2. That is the center of mass, the coordinate of the center of mass of a particle or of a system which are having the particles of the same mass. If you are having n number of masses, so that is m1 x1 divided by m1 plus m2 plus m, etc. up to mn, that is the total mass, plus m2 x2 divided by m1 plus m2 plus etc. up to mn, that is total mass again. So overall, m1 x1 plus m2 x2 plus etc. up to mn xn divided by m1 plus m2 plus etc. up to mn. Here we have, in the first initial case, we have considered only the two particles. So where it was m1 x1 plus m2 x2. Now you are having n particles, that is m3 x3 plus etc. up to mn xn, all divided by the total mass, that is m1 plus m2 plus m3 plus etc. plus mn. Okay. So with the help of the summation, you can write that one as summation of I is equal to 1 to n mi xi, that is m1 x1 plus m2 x2 plus m2 etc. up to mn xn, divided by summation of I is equal to 1 to n mi, that is m1 plus m2 plus etc. up to mn, where the summation of I is equal to 1 to n mi is actually the total mass. Okay. So if you are having n number of particles are linearly arranged, then to find out the center of mass, the general equation to find out the center of mass is summation of mi xi divided by mi. Okay. Now, suppose if the particle is arranged in a plane, that is xy plane, then you have to consider the two coordinates linearly in the beginning. Or earlier we have considered only a linear arrangement of the particle. Now in a plane the particles are arranged. Hence you have to introduce the other one of the axis of the coordinate, that is x and y axis. So for the center of mass also there will be two coordinates, that are the x coordinate and the y coordinate. So first of all you have to find out the x coordinate. So the particle m1 is at a point x1 and y1. So we can say m1 is at x1 y1, m2 is at x2 y2, and m3 is at x3 y3. Then the x coordinate of the center of mass will be m1 into x1 plus m2 into x2 plus m3 into x3 divided by m1 plus m2 plus m3. And y coordinate of the center of mass will be m1 into y1 plus m2 into y2 plus m3 into y3 divided by m1 plus m2 plus m3. Okay. So the mass of, if you want to find out the x coordinate, first mass into its x coordinate, second mass into its x coordinate, third mass into its x coordinate. Okay. And divided by the total m1 plus m2 plus m3. As well, if you want to find out the y coordinate, first mass into its y coordinate, second mass into its y coordinate, and third mass into its y coordinate, and all sum. You have to take the sum of all three divided by m1 plus m2 plus m3. And suppose if m1 is equal to m2 is equal to m3, then x will be m into x1 plus x2 plus x3 divided by 3m, that is x1 plus x2 plus x3 divided by 3, and y will be y1 plus y2 plus y3 divided by 3, where capital X and capital Y are the center of mass, the coordinates of the center of mass, that is x, y. The center of mass is located at the point x, y. Okay. Now let us consider the motion of the center of mass. So we have already studied that mass, the total mass into where r, capital R is the coordinate of the center of the mass, will be is equal to summation of mi ri, that is m1 r1 plus m2 r2 plus etc. up to m rn, where r1 is the position vector of m1, r2 is the position vector of m2, rn is the position vector of mn. Now you are taking, or you are differentiating both sides with respect to the time. So m into dr by dt. Position vector, that means actually the displacement. Displacement divided by time. That is the velocity. So dr by dt, the d capital R by dt is actually the velocity of the center of mass, which is equal to m1 v1 plus m2 v2 plus etc. up to mn vn. So the total mass into the velocity of the center of mass will be is equal to mass, the first particle's mass into its velocity plus second particle's mass into its velocity, and etc. up to end mass into the its velocity. Now again you are differentiating this equation, that is mv is equal to m1 v1 plus m2 v2 plus etc. up to mn vn dv by dt. That is m into dv by dt is equal to m1 into dv1 by dt plus m2 into dv2 by dt plus etc. up to mn into dvn by dt. dv by dt, that is the velocity divided by time, the instantaneous acceleration value dv by dt. So m into capital A, where this capital M, it is representing the total mass of the system, and capital A is representing the acceleration of the center of mass, that is equal to m1 plus m2 plus etc. up to mn where m1 is the mass of the first particle, a1 is the mass of the acceleration of the first particle. Likewise, second m2 is the mass of the second particle into the acceleration of the second particle. Likewise, you know that mass into acceleration is actually the force. So here m into a, the center of total mass into the acceleration of the center of mass, is actually f1 plus f2 plus etc. up to fn, where f1 is the external force acting upon the particle 1, f2 is the external force acting upon the particle 2, and fn is the external force acting upon the nth particle. Okay. Now, why this external force? So you know that in the case of the system of a particle, the internal forces will get cancelled each other. So center of mass of the system of particle moves as if all the mass of the system was concentrated at the center of mass and all the external forces were applied at that point. So the external forces are acting upon the point where the center of mass is situated. Okay. So here the mass, total mass into the acceleration of the center of mass will be is equal to the total external forces. Here external f is represented or specified as external, that is only the external forces are under the consideration. So internal forces, due to the random movement of the particle or the random arrangement of the particle, the external forces the internal forces will get cancelled each other. Okay, and the total net internal force will be 0. Now, linear momentum of a system of particle. So you know that P is equal to m into v, and from the Newton's second law of motion, that is F is equal to dp by dt. Now we have already seen that is mv is equal to the capital M into v is equal to m1 v1 plus m2 v2 plus likewise. So where mass into velocity is actually the momentum. So the momentum of center of mass is actually the momentum, the sum of the momentums of each particles. Okay. So m1 v1 plus m2 v2 plus etc. up to mn vn. So we can say the total momentum of system of particles is equal to the product of the total mass of the system and the velocity of its center of mass. That is the total momentum of the system of particles. Otherwise, it's the sum of the product of mass and velocity of each particles. So where now you are differentiating dp by dt, that is m into dv by dt. Already you are having p as mv, so substituting the v value here, that is m into dv by dt will be there. dv by dt it is actually a, where capital V is the velocity of the center of mass, a is the acceleration of the center of mass. So m into a is actually the f external. So dp by dt is equal to f external. That is the Newton's second law of motion extended to a system of particles. As you are considering a system of particles, so the Newton's second law of modified Newton's second law of motion for the system of particles is actually dp by dt is equal to f external. Now we have to consider, as dp by dt is equal to f external, we have to consider the conservation of momentum. That is, suppose f external is equal to 0. A conserved force, it is external, f external is equal to 0. There is no external force if it is there. Then dp by dt will be is equal to 0. That means p will be a constant. P will be a constant. That is, if there is no external force is acting upon the system of particles, then the momentum it is conserved and the momentum value will be constant. Okay. Now let us come to the most important portion, that is the vector product of two vectors. So we have already studied the scalar product of the vectors, that is the dot product. Suppose if we are taking the vectors a and b and a dot b, and its magnitude will be ab cos theta. We have studied that one. Now this is the vector product, that is the cross product. That is if you are considering two vectors, vector a and vector b, the cross product is actually a cross b, and its magnitude will be ab sine theta, where theta is the angle between a and b. Now the definition of vector product: a vector product of two vectors a and b is a vector c such that magnitude of c is equal to ab sine theta, where a and b are the magnitudes of vector a and b, and theta is the angle between the two vectors, and the c is always perpendicular to the plane containing a and b. The vector product of two vectors a and b always will be perpendicular to the plane where the a and b lies. Now if you take a right-handed screw with its head lying in the plane of a and b and the screw perpendicular to this plane, and if you turn the head in the direction from a to b, then the tip of the screw advances in the direction of c. That is actually the right hand thumb rule, or here you can see the right hand the screw rule. So the representation is given. So here suppose if you are taking the cross product, okay, that is a cross b, from a to b if you are taking, that means you are rotating the screw in the, you can say, if you are observing from the bottom side, from here if you are observing, it is in the clockwise direction you are rotating. So as you are rotating it in the clockwise direction, the screw will move into the plane, that is upward it will move. That is if you are taking the cross product from a to b, that is a cross b, if you are taking, the direction of the product, that is c, will be upward. Instead of that, if you are taking the b cross a, the movement of the screw will be downwards, that is b cross a will be in the opposite direction. Okay, so from b to a you are rotating the screw, the anti-clockwise direction you are rotating, that means in the, as you are rotating the anti-clockwise direction, the screw will come out of the plane, isn't it? So that is towards the down, the direction of the cross product of b cross a will be downwards and a cross b will be upwards. So we can say a cross b is equal to minus of b cross a. But in the case of a dot b was equal to b dot a. But here the negative, a cross b is equal to minus of the b cross a. Thus we can say the cross product is not commutative. The vector products are not commutative. And another interesting facts are the image formed of the vector product. That is, if you are taking the image that is a, the image of a is minus a, and the image of b it is minus b, then a cross b, and its image will be minus a cross minus b, that will be a cross b only. That is, there is no change in the reflection, there is no sign change under the reflection. Now let us come to the distribution. If you are following the distribution, that is a cross of b plus c, that is actually a cross b plus a cross c. So both the scalar and vector products are following the distributive law. Now if you are taking the cross product of a dot a was equal to a square. But here in this case of the a cross a, A cross A will be 0 always. If we are taking the cross product of same vector, that will be always 0. So let us see, that is I cross I, j cross j and k cross k all are 0. But at that time I dot I is equal to j dot j and k dot k. All values were equal to 1. But here I cross I, j cross j and k cross k is equal to 0. And as well I cross j is equal to k. For that one, you can, with the help of the coordinate system, you can see that this one you take as I, j and k, and you have to represent a clockwise direction. That is, if you are taking the cross product from I to j, I cross j it will be k, j cross k it will be I, j cross k it will be I, and k cross I it will be j. But at the time if you are taking it from k cross j, it will be minus I in the opposite direction it is taking, so minus I. J cross I will be minus k, and I cross k will be minus j. Okay. So with the help of this diagram, you can remind this time, so these equations. Okay, these are important things for the vector. As you are considering the vector product, these are some major points. So with the help of that diagram, you can easily remember these terms. Okay. Now let us come to the vector product. So you are having two vectors A and B. One it is Ax I cap plus Ay j cap plus Az k cap, and Bx I cap plus By j cap and Bz k cap. So you are taking the cross product. So first of all, Ax I cap with Bx I cap, where I cap both are same. So I cap cross I cap will be 0. So that term will be 0. Now the next one it is Ax I cap plus By j cap. So Ax By, the I cross j will be k cap. Now the next one it is Ax I cap plus Bz k cap. So Ax Bz, the I cross k will be there, that is minus of j. So these two terms are fine. Now afterwards, you have to consider the Ay j cap. Ay j cap, Bx I cap. J cross I minus k will be there. And Ay Bx. Next one, Ay j cap cross By j cap. That is Ay By j cap cross j cap 0. So likewise you just solve all the terms and you will get the result as this one. This is the cross product of A cross B. If A is equal to X I cap plus Ay j cap plus Az k cap, and B is equal to Bx I cap plus By j cap and Bz k cap. Okay. And easily you can solve this one with the help of the determinant. Okay. How to do the determinant? So you are having A as Ax I cap plus Ay j cap plus Az k cap, and B as Bx I cap plus By j cap plus Bz k cap. For solving this one, we can use the A cross B is equal to determinant of, on the first row you will be having I, j and k. Next row, the x component, y component, z components of the A, that is Ax, Ay and Az. Third one, Bx, By and Bz. Okay. So it is given here. Ijk, then x, y, z components of A respectively written below I and j and k respectively, then Bx, By and Bz. Now how to solve this one? So here you are having I, j, k, Ax, Ay, Az, Bx, By, Bz. Suppose if you are considering the I, so I into I के बाद, so you have to neglect the term i's row and column, the column which is having I and as well the column row which is having I. So now you are having Ay Bz and By Az. So Ay bz minus, okay, from this to this minus this to this, by az, by az. So I term it is over. Now next term, second term j. For j you have to write minus j. For j you have to discard the column and as well the row which are having the j terms. Now the terms remaining will be ax, bx, az, bz. So minus of j into ax, bz minus az, bx. Okay. Now the next term it is k plus k. So I plus I minus j plus k into az and bz terms will be as, because k, the row which is having k, column of k and the row of k will be cancelled, and the remaining will be ax, by and bx, az. So ax, by minus bx, ay. Ax, by minus bx, ay. Okay, bx, ay. So now you just open this bracket and check or compare that along with the vector product that you have already obtained here. Okay, so that will be same only. So if you are having two products, if you want to take the cross product of two vectors a and b, yeah, you can do that one with the help of the determination or determinant method. Okay, this much things you study and read the textbook very well and go through the example questions also. Okay, so thank you.